the infinite geometric series formula is very similar to the geometric series formula. So if you know this one, that one becomes a lot easier to remember. And this is why. The infinite geometric series only works if the ratio, well, first I have to give you this, if the ratio is less than 1. If the ratio is less than 1, then it works. But then you talk about negatives, and so you have to say the absolute value of the ratio. If the absolute value of the ratio is less than 1, then you can do it. You can find the sum of an infinite geometric series. Or you can say it this way: if the ratio is a fraction or decimal, okay. If the ratio is a fraction but is not an improper fraction, then you can use the infinite geometric series. Like you can find the sum. Okay. This is probably the most simplified way to say it, or you can just think about it being a fraction, but it can't be an improper fraction. If it's an improper fraction, then it's a mixed number. Mixed numbers can be decimals also, but they have a number in front of the decimal besides 0. But anyways, so let's think about that for a second. What if this r right here was less than 1? It'd be a fraction, right? Let's put a fraction in there that's less than 1, just so we can have a visual. 1/2? So we have 1 minus 1/2 raised to the infinite power divided by 1 minus 1/2. Okay, now what happens to that fraction? As we're raising it to the infinite power, what is happening to that fraction? It's getting smaller and smaller and smaller, because when we raise 1 to the next power, it just stays 1, right? But if we raise 2 to the next power, it gets bigger. And 2 raised to the 20th power, it's going to be a really big number, right? It's going to be really big. And if you're approaching infinity, it's going to get ginormous on the denominator. So what is happening to that number? It's getting closer and closer and closer to
0.
Now, does that ever really get to 0?
No.
No. And this is where it's kind of weird, because if it's raised to the or to the infinite power, it technically does get to 0. Which is kind of weird. This is a calculus concept, and you're going to see this again for the next 2 years. Because this the power is infinite, the fraction will go to 0. And so pretty much it's gone when you're talking about an infinite series. It just goes away. Okay, because it takes that fraction and zeroes it out. And so what am I left with? I'm left with a sub 1 times 1 over 1 minus 1/2, which is our r. And we can simplify this by going a times 1. And that gives us our formula. Our formula is, of an infinite series, is a sub 1 over 1 minus r. It's a really pretty formula. It's really simple, really nice. A lot nicer than this one looks. Okay, so let's see how that works. Here for our first one, our common ratio is 0.6. That's our r. Can we find the sum of this infinite series?
Yes.
Yeah. Okay, that's not an improper fraction. The absolute value of that r is less than 1. Okay, so how will we do this? Oh, we just use the formula. That's it. Just gotta use the formula. Just gotta use the formula. S sub infinity equals a sub 1. So our first term, well, what would happen if we plug in 1 right there? That would be a 0. This would go to 1. So our first term would be 4. So 4 over 1 minus 0.6. 1 minus 0.6 is 0.4. And we have a 4 up top. If we go 4 divided by 0.4, we get 10. And that's it. That's kind of weird, though. Like if we're having an infinite amount of numbers right here, an infinite amount, and then we get 10. What? That's really bizarre. Infinity within a finite number. Blows my mind. Alright, okay, what about over here? In order to find this one, we know it's infinite, by the way, because of these dot dot dots right there. What is our common ratio, and how would we find it? We would take 0.3, divide that by 3. You take 0.3, divide it by a previous number to find the ratio between those two. When I do that, I get 0.1. Well, is it a common ratio? I don't know. Let's try it. 0.03 divided by, 0.03 divided by the previous one would be 0.03, no, 3. And that would also give you 0.1. Oh, cool. So it is a common ratio. So my common ratio for this one is 0.1. Let's use our formula now. S sub infinity equals our first term. What's our first term? 3 divided by 1 minus 0.1. What is 1 minus 0.1? 0.9. So what is 3 divided by 0.9? I should have known that. Anyways, 3.3, and I'm just going to put a repeater bar right there. Now, so you could do the repeater bar, or you can go 3, 3, 3, and put 3 dots after it. So that would be the sum of this one right there.